So good morning or good afternoon, everyone. Welcome to the workshop. I see that the participant just arrived. We can wait a few seconds more to be sure that everyone is able to be online. And so you are welcome to this workshop. This workshop is dedicated to the report of the task group from ICRP on radiological protection in areas contaminated by past activities. So I am Thierry Schneider, the chair of Committee 4 of ICRP, and this is my pleasure today to introduce this workshop and also to welcome all the participants, because we heard that we have around 700 people who register for the workshop. So this is interesting to see the success and the interest on the topic. And this is our pleasure to give an overview today to the report which have been prepared by the task group. So first of all, in introduction, I would like to remind you or to explain you the origin of the task group. The task group have been set up to further investigate the application of the system of radiological protection, specifically for existing exposure situation. Existing exposure situation has been introduced by publication 103 in 2007. And then the Committee 4 has been in charge after the publication to investigate what does it mean more concretely, the application of the system in different type of existing exposure situations. So we have already published some report on the management of norm activity, the management of radon. We have also some discussion on the application of radiological protection for air crew and people in the plane. We also have some discussion on post-accident situations. So you have already a series, and today this is our pleasure to show you where we are with all the development in terms of application for past area contaminated by past activities. In fact, this topic is not new. It has already been addressed or still being addressed by either international organization, and we have worked closely with IAEA and NEA in order not to duplicate what has been done, but really to highlight the key element with regard to ICRP recommendation in this domain. This work clearly addresses the current reflection of ICRP on the application of justification, optimization, but also with regard to the selection of relevant radiological criteria. And there is due consideration of ethical values and stakeholder participation. So you will see in the following presentation and in the report how these aspects have been introduced and are key elements, notably with regard to the application in existing exposure situation. The preparation of this report has been made under the leadership of Mike Boyd. Mike used to be at the US EPA, the director of the Center for Science and Technology in the Radiation Protection Division. Mike has a long experience in radiation protection and in international organization, member of ICRP since many years and chairing the task group since the beginning with a huge activity. And I really want to thank him for his work and all the team who work with him, and especially Analia Canova, who co-chair the task group, and she will make also a presentation. So with that, I really want to thank all the members, and especially you will see one of the specificities of the report is to rely on case study, a real experience, and the member of the task group were really able to share their experience and to highlight what are the key elements to be addressed in terms of management of area contaminated by past activities. In fact, a preliminary version of this report has been reviewed by experts from IAEA, NEA, and European Commission, and this is really a pleasure to have exchange with them, and all these exchange allow to produce an improved document which is now ready for public consultation. So I just remind you before to give the floor to Mike that the public consultation is open till the 20th of September. So you are welcome to make your comment and suggestion for improving the report, but also to identify some further topic of development for the continuation of activity of ICRP. With that, this is my pleasure to give the floor to Mike Boyd for the first presentation.
Thank you, Terry, and hello, everyone. I'm so happy that so many of you have joined us today. We're going to have three presentations now. I'm going to give an overview of the report. Analia, the task group co-chair, will give a presentation on the implementation of the system of protection for contaminated sites. And then we'll have one of our case studies presented by Stephen Long from Arpanza in Australia on the Maralinga site. So, as noted in the chat, you can put your questions in the Q&A box at the bottom, and we will be answering them following the presentations this morning or this afternoon, depending on where you are. So let's get started. I'll share my screen. No matter how many times you practice, there's always a problem. Sorry, forgot to restart the set here. So welcome. We're going to talk about the system, how the system of radiological protection relates to the management of contaminated sites. Are my slides coming through okay? Yes. This is the membership of the task group. You'll notice that we have experts from around the world and well represented by regions. Our terms of reference were to describe and clarify the application of the Commission's recommendations on the radiological protection of workers, the public, and the environment. And the scope included sites contaminated from past industrial, military, and nuclear activities. That includes residual activity never subject to radiological control or not controlled according to ICRP current recommendations. The report will consider characterization of sources, exposure pathways, dose distribution, categories of exposure, protection of the environment, and the setting of reference levels for sustainable protection strategies. And we were asked to consider stakeholder involvement in all steps. The Task Group 98 does not address the planned remediation of areas as part of the operation or decommissioning of facilities that were continuously maintained under adequate regulatory control, or in cases of contamination of localized areas within the site boundary of an authorized facility, which are treated in the framework of planned exposure situations. So these are not included in our report. Also, emergency exposure situations in case of a severe nuclear power plant accident and the subsequent post-accidental phase, which are addressed in publication 146, are similarly not considered in the scope of our publication. So as is typical with most of the recent ICRP reports, we distill our report into a few main points, usually no more than 5. So I'd like to go through those 5 points as a way of sort of summarizing a lot of what the report is focused on. And our first main point was that the Commission recommends managing exposures in areas contaminated by past activities as existing exposure situations. And then there's this sentence with a lot of terms I'll want to explain to you, where we say a graded and integrated all hazards approach should be taken for the protection of workers, the public, and the environment, addressing actual exposures and exposures not certain to occur, both now and in the future. So let's go through these highlighted terms. Of course, existing exposure situations are defined in publication 103. If you look on the ICRP.org website under the ICRP ICRpedia, glossary, you'll see that a graded approach is defined there as meaning that implementing the system of protection in a way that is proportionate to the magnitude and likelihood of the risk, the complexity of the exposure situation, and the prevailing circumstances. So basically what a graded approach means is you apply as much effort to a problem as the problem requires, and not, and as a means of allocating resources. Integrated approach means remedial actions should be taken to ensure both the protection of people and the environment. Since publication 103, there have been quite a few publications related to protection of the environment, and the advice here is to look at both protection of people and the environment in an integrated approach. An all hazards approach then means to look at radiological and non-radiological hazards together to define the best protection strategy, noting that in some cases it's the non-radiological hazards that are the most significant at a contaminated site in some cases. And exposure is not certain to occur is a term of art, I think, that we've come up with in Task Group 98 to mean exposures arising from contaminated areas over the medium and long term that are not expected to be delivered with certainty. And we chose this term to avoid confusion with the term potential exposures, which are defined in publication 103 in the context of planned exposure situations only. So exposures not certain to occur are sort of kind of like potential exposures, but in the context of existing exposure situations. So now our second main point is that the remediation process underpins the management of contaminated areas and encompasses 5 phases from recognition to post-remediation management. I'm not going to focus on this, and because Analia is going to be giving a presentation on this topic in the presentation following mine. The third main point is that early, broad, and ongoing stakeholder involvement in the remediation process, including the selection of relevant radiological criteria, is central to a sustainable strategy. And we believe that stakeholder involvement is a key aspect of most successful contaminated site remediation projects. And an example will be featured in the case study presentation today by Stephen Long for the Maralinga site in Australia. Noting that the ethical foundation for stakeholder involvement is featured in Task Group 98's section on justification, and the role of stakeholders is highlighted in the description of the optimization process in our report. So our fourth main point is that the reference level for public protection should be selected in the lower range of the 1 to 20 millisievert per year dose band, with the objective to progressively reduce exposures close to 1 millisievert per year as the site situation improves. And Task Group 98's approach for managing public protection in existing exposure situations is consistent with recent ICRP publications, notably publication 146 for managing exposures in the long-term phase following a large nuclear accident, and publication 142 for managing naturally occurring radioactive material exposures arising from industrial processes, with radon and thoron being treated separately according to publication 126, it should be noted. This advice is supported by practical experience as described in our case studies. Of course, we also recommend in our report the need for flexibility, and there are possibly cases where it would be impossible to get down to 1 millisievert. We recognize that, so I wanted to make that point. Remediation workers are, in most circumstances, this is our fifth main point, managed as occupationally exposed workers. I think there's been a lot of discussion around the implementation of publication 103 about how to treat occupational workers. But nevertheless, the Commission recognizes that flexibility in the use of regulatory tools to achieve protection may be required to implement an adequate protection strategy. And this subject will be discussed in Analia's presentation following mine. So those are our 5 main points. There's a lot more interesting material in the report, and I encourage all of you to look at the public consultation version and give us your views. The structure of the report is as follows. We have section 2. Section 1, of course, is just the introduction. Section 2 presents the characteristics of exposures associated with areas contaminated by past activities based on the case studies described in the annex. Section 3 describes the Commission's system of radiological protection applied to exposures resulting from areas contaminated from past human activities. And this includes the type of exposure situations, the categories of exposure concerned, and the basic principles to be applied. For existing exposure situations, as you know, we apply the principles of justification and optimization. Section 4 provides guidance on the implementation of the system of radiological protection. As I've said, this is our next presentation. And on the environment and remediation workers over the lifetime of the remediation process. Section 5 is a summary, and the case studies are presented in the annex. So there are some contemporary issues that we try to cover in our report. And this is by no means all of them, but we do discuss the management of occupational exposures in existing exposure situations, sustainability and stakeholder involvement, which have become increasingly prominent issues in the recent publications of the ICRP, the ethical foundation of the system of radiological protection, protection of the environment, and as I said, exposure is not certain to occur. I'll go through these now. For occupational exposures, radiation doses to remediation workers should be managed as planned exposures when the existing exposure situation is well characterized and exposure pathways can be controlled. A graded approach should be applied to the management of workers who are exposed exceptionally or episodically, and Leah will tell you a bit more about what we mean by this. And there are more details on the treatment of occupational exposures provided as well in the next presentation. For sustainability and stakeholder involvement, we note that early, broad, and ongoing stakeholder involvement is central to designing and implementing a successful sustainable remediation strategy. The protection strategy to control exposures from contaminated areas should take into account health, economic, environmental, societal, cultural, and ethical considerations, as well as other specific local considerations from local stakeholders. And we also note that a co-expertise process of cooperation between experts, professionals, and local stakeholders allows for sharing local knowledge and scientific expertise, both from the local residents and the experts in the process, to evaluate and better understand the radiological situation, to develop protective actions to protect people in the environment, and to improve living and working conditions. There's quite a bit more on sustainability throughout the report, and I invite you to review that. The ethical foundations. Task Group 98 does incorporate the ethical values outlined in publication 138. The 4 core ethical values of beneficence, non-maleficence, prudence, justice, and dignity are considered an integral part of the recommended protection strategies for managing exposures associated with contaminated sites. So the first 3, let's see. Yes, the values of beneficence, non-maleficence, prudence, and dignity support a broad view of justification that considers the well-being of individuals and the environment now and across future generations. In the optimization process, the use of reference levels as individual dose criteria prevents serious inequity in the distribution of individual doses to humans in line with the ethical value of justice. So all 4 values are reflected in the report. For protection of the environment, although not listed in the 3 categories of exposure identified in publication 103, ICRP also extended the system of protection to address the protection of the environment, including flora and fauna, more explicitly, noting that remediation of contaminated areas should consider the protection of human and non-human biota in an integrated manner. Environmental radiological protection includes more than protecting flora and fauna, however. It includes the conservation of other ecosystem components such as air, water, soils, sediments, and habitats. and efforts devoted to the assessment of the impacts on flora and fauna should be commensurate with the level of risk. Now to that term of art, we're using exposures not certain to occur. Potential exposures are defined in publication 103 as those arising in planned exposure situations as a result of deviations from normal operating procedures, including accidents and malicious events. Management of contaminated sites may also require consideration of exposures that are possible but not certain to occur for the different protection strategies. So as I mentioned, to avoid confusion, we're using this term of exposures not certain to occur in the context of existing exposure situations. Assessments of these exposures should be reasonably realistic instead of focusing on highly unlikely scenarios. The probability of an event and its consequences can be evaluated to assess the risk. And among our case studies, the Dalgety Bay case study from Scotland provides a useful example, and this is discrete particles of radium which are distributed, probabilistically, and you will, I think you'll find that case study very interesting as well. So, giving you a quick overview of the case studies before I turn the presentation over to Analia, we do provide 5 case studies in the report. Many remediation decisions in these examples predate the latest general recommendations of the ICRP. So we have identified the equivalent, in some cases they are called reference levels. In some cases, we have identified what the reference level would be, even though that term may not have been used at the time of the remediation. So I would say that nevertheless, most of the implementation strategies adopted at these sites are compatible with the current recommendations. The first case study we offer is the Rocky Flats plant near Denver, Colorado. It illustrates the stakeholder involvement process and prospective dose assessment. The land was and is unoccupied. The radionuclide of concern there is plutonium-239, and a reference level of 0.15 millisieverts per year is provided. The second case study is the one you'll hear about later, is the former above-ground nuclear test site at Maralinga that covers 3,300 square kilometers in southern Australia. This example will be presented later in this report. The third case study is the remediation of radium contamination in the Swiss watch industry, and it illustrates the setting of reference levels in a contaminated area that was not primarily land, mostly buildings. The radionuclide of concern is radium-226 from radium dials, and there's a reference level of 1 millisievert per year. Our fourth case study is the Techa River site in the Chelyabinsk region of the Ural Mountains in the former Soviet Union, which is now the Russian Federation. It illustrates a complex site where past, present, and future exposures need to be considered, along with evaluation of radionuclide transport and land use restrictions. The radionuclides of concern there are mixed fission products, including strontium-90 and cesium-137. For this site, a reference level has not been established. And finally, the fifth case study involves radium-226 contamination from a former airfield and aircraft servicing base that operated from 1917 to 1959 in Dalgety Bay in Scotland in the United Kingdom. The radionuclide of concern is radium-226 in the form of discrete particles, and the remediation goal for the exposures not certain to occur is that the current or future probability of an individual receiving 1 millisievert committed effective dose should be less than 10 to the minus 6, 1 in a million per year. And with that, I think I'm finished. I finished a little early, so I think that gives Analia a little more time to talk about the implementation. Analia Canova, I'll turn it over to you.
Okay, thank you, Mike. Thank you very much. And hello to everybody. I will try to share my presentation. Okay. Okay. Can you see it? Okay. Well, thank you very much, Mike, and welcome to everybody. I'm going to describe which are the steps involved in the remediation process for the implementation of protection. And the idea is to describe how the principles of protection and the tools, how the system is implemented through the 5 main steps that are identified. These are first, the recognition of the exposure situation. After that, the characterization of this situation. Then the planning of remediation step, the implementation of the remediation action plan, and finally, the post-remediation management. I'm going to try to describe the characteristics of each step. In first step, the recognition of the exposure situation, this is the focus on the initial recognition, and we need to collect all the available information and the history of the site. Something that it is a challenge, but it is very important, is to identify the ownership of the area, the physical ownership, the legal and financial. And for the very beginning, as Mike mentioned, it is very important to identify the stakeholders involved, the local community involved, and that will be affected by the site. So to try to collect the knowledge of the history of the affected area, and it's very important to start the communication and engagement in this process, because you will see in the document, as Mike also mentions as the main point, it is important to understand which are the values involved for the local stakeholders, because this is important to address in justifying, optimizing, and selecting a remediation option. Also, as Mike mentioned, these sites are complicated because you don't only have radiation radionuclides. You have other hazards, so it is a multi-hazard site. So it is needed to work together and try to identify the different regulatory authorities involved and to define the responsibilities, because finally something very important is to have a common and shared understanding of which are these main features of the area. So after that, the second step is how to perform a characterization of the exposure situation, because also, as Mike mentions, they are in the framework of existing exposure situations, and you know that to take reasonable and appropriate decisions, you need to have the information of the site and to know which is the magnitude of the problem of the situation to take actions. So in this sense, a detailed evaluation, you need to determine which are the radionuclides, the main exposure pathways, which is also, it is in the site, and then which is the dispersion of the extension of this contaminated area. And the idea is to have to perform the risk, the dose assessment to people and the environment, the current situation and what will happen in the future also. So in this stage, you have to perform the monitoring, the sampling, measurements, also to apply the modeling, to have this, try to define which is the conceptual model of the site. It is important also to know which are the specific environmental characteristics of the site, which is the hydrogeology, which is the soil types, which are the characteristics of this soil, the topography, which is the land use of the site. Also very important is to collect the baseline information of the radiation levels because in all the decision-making process, it's important to try to address clearly which is the contamination caused by the past activity. And this is very important, for example, if you have a legacy site from norm, where you have radionuclides that take part of the background. It is important to identify the receptors, which are the affected members of the public, then try to define which is the representative person that you have to define, which are those, and also the non-human biota receptors. Regarding how to perform the dose assessments is trying to apply realistic scenarios as much as possible and trying to avoid over-conservative assumptions. And also, as Mike mentioned, it is important to address which are the exposures that you don't have a certain probability that this will happen in the medium and long term. So, and we recommend this term, exposure not certain to occur, but it's the idea of potential exposures in plant exposure situation. But again, although they are of probabilistic nature, the idea is not to focus on very high unlikely scenarios, because the results that you will have will affect the resources and all the decision making process. The characterization not only involves radionuclides or radioactivity. We need to know which are the other hazards. More common, you know, is the contamination with metals, lead, mercury. You can have cadmium, arsenic, asbestos. You will have other hazards, and this is very important from an holistic management of the site. And what we call, for example, site context factors. These are very important, as you will see when you read our document. We talk a lot about the prevailing circumstances, that are the circumstances that you have to take into account in a holistic approach to the decision. The economics, the resources, the social and cultural values of the people of the area, sustainable factors. Then we will analyze the technical feasibility to do something in the site, to improve the site. Which are the waste management aspects? You will see waste management is an important factor in remediation process. Which is the surrounding population. It's a small population, a high population, is near, it is far. What are their habits? And as I mentioned again, is the stakeholder values, what is important for them. All this detailed characterization is very important because it's a key input to the justification process of the remediation and to justify a protection strategy. And also it is very, very much important, essential, how to apply the optimization process. When we mention local communities involvement, we are saying to share information. It is a dialogue. It's not just giving the authorities the information. And in this characterization, it's very important that they can take part of it, and that people begin to understand which are the risks are involved. And this, of course, from the very beginning is propens to build trust and confidence to the people. Then, if the implementation of strategies justify taking into account all these prevailing circumstances and factors, the third stage begins. It is the remediation planning begins. We have to bear in mind which is the objective of the process. And the objective is not just dose reduction, is to achieve an overall well-being, taking into account all the hazards of the site and taking into account these context factors, the prevailing circumstances. In this planning of remediation, we need to perform a complete evaluation of the risk to public, the workers that could be involved in the remediation process, and the environment, and also addressing risk from the site. And we can say that we have risk off-site, for example, from waste management activities. Then, in this stage, the remedial actions are investigated, are considered, and evaluated. And we need to establish a reference level for the residual dose. Also, what we call an end state that is different for the reference level. It is an optimized dose criteria below the reference level. And this end state has to be carefully also selected. We have to take into account which are the societal, economic, and environmental contexts on the site. And something very important that sometimes is a little challenge to select has to be in line with the future use of the site. Sometimes you know that there are many complex situations that require too much time. So sometimes it is possible for the management of the site to have some interim states. And this allows to adapt the authorities and the people to the management to have a progress towards a final state. Sometimes it's not easy to perform these issues in one step. Just to remind that which is the definition of optimization of protection for ICRP 103, in this line, it is an iterative process where the distribution of individual dose, the idea is to move forward, downwards, stepwise, to progressively improve the situation until the level of protection is achieved and this level is considered optimized. In the planning is very much needed the coordination between the different authorities and to realize and define which are the responsibilities of each of them. In this stage, the stakeholder input in this process, again, share the values and knowledge to express their concern when the discussion and evaluation of the possible decisions. And something important is that in these decisions, you have uncertainty. Sometimes it is impossible to know all the information. Maybe you can improve this, but for example, performing more monitoring. But there are cases that you don't know and you have to assume some parameters. So it is important to realize and to communicate which are these uncertainties and the impact that they may have in the decision-making process. It has to be a transparent communication in this sense. And it's important from the stakeholders that they understand the implications and also the benefits of taking actions. Once the option is selected, a site-specific action plan should be defined that should have this information, all the information of the site, which are the objectives of the planning of remediation, which is the reference level, the end states, the remedial actions, the safety and environmental assessment performed, which are the monitorings that have to be performed, and also the post-remediation actions, including the institutional control if decided and needed. So we are going to describe briefly how to address protection of the public, the environment, and the workers. So protecting the public involves establishing a reference level. And to define this reference level, you have to know the characterization, you have to perform the characterization of the site and the context of the situation. So in the factors, you need the characteristic of the exposure, the feasibility, if it's possible to implement actions or not, which is the time involved and the cost of remediation, which, for example, are the volume of waste and residues generated. It will have an impact on the environment or not. For example, the options, the strategy will produce some societal disruption. What will be this disruption? And also take into account, of course, experience in the management of similar situations. So that is why, and we discussed a lot at the beginning of the task group, because we wanted to be more specific and to give more recommendation about the reference level, but we have to recognize that these situations are unique. So you cannot establish a receipt of the reference level. So the reference level is determined on a case-by-case basis. And as we mentioned, we take into account in the reference level, this exposure is not certain to occur. We recommend to follow how to manage the uncertainties of the exposure scenarios with the publication 101A, and also how to address the representative person. And as Mike mentions, so the recommendation is generic, but a little more than 103, is to select the reference level in the lower half of the 120 millisievert per year band, with long-term objective of progressively reduce exposure close to 1 millisievert if it is possible. One aspect is that this reference level selected does not include radon exposure and background exposure. And that the end point of remediation is an optimized dose below the reference level. Something very important to bear in mind, that optimization of protection is not minimization of dose, or not the minimization of a single attribute of this factor that we are taking into account. Is to achieve, it is to have the best under the prevailing circumstances. So we emphasize that the most appropriate option may not be the one resulted in the lowest dose. And something that also we discussed in the task group is that in specific circumstances, and I highlight this, in specific circumstances, and if it is agreed between authorities and a stakeholder because it is really needed, the reference level could be a value below 1 millisievert per year. Radon management is in accordance with publication 126. based on optimization of the principle and applying, as you know, a derivative reference level of 100-300 becquerel per cubic meter. And if radon is concentration is performance above the reference level, so further assessment is has to be followed, applying the graded approach as is described in publication 126. Public dose assessment has to be performed from exposure from the site, during remedial work, and during waste disposal and post-remediation. Also, you will find in the text a paragraph regarding health surveillance that also we discuss a lot, because some people say, well, it is not needed in these legacy sites because of what are the dose and the risk involved. But we introduce a paragraph about that some stakeholders could be concerned, and it's important with the authorities to start a dialogue and to explain which will be or not the objective of this health surveillance. Protecting the environment. And as Mike mentions, we recommend an integrated approach, ensure both protection of people and the environment, and to follow the different publications of ICRP, mainly 108 and 125, with the concept of the RAPS and the river consideration reference level as tool for management of this non-human biota, taking into account that we need to assess an environmental risk to determine which are the adverse impact of the ecological receptors, including the habitat disruption that could have to the natural resources, aquifers, soils, these remediation options. And to remind that flora and fauna populations are addressed as population, not as individuals, and we have to address also the different components of ecosystem for protection. As it is recommended in publications from ICRP, to determine these delivered consideration reference levels, the recommendations to follow a graded approach, starting from a generic assessment with generic parameters, and then, as needed, a specific assessment, or use a further detailed site-specific risk assessment. Just to remind that when you analyze the options, it's not only, when we talk about the protection of the environment, it's not only to analyze the values of those rates that you measure with this delivered consideration reference level, is this, but much furthermore is to analyze the factor beyond this estimated dose to see which are the impacts of the environment as a whole. You will find that we discuss also a lot in the task group, some references, it's just some reference that we recognize, ICRP recognize that it is increasing interest in other fields of incorporating in environmental protection, is the concept of ecosystem services monitoring. We recognize that this is used in other fields, and indeed there is a task group that is ongoing, task group 125, to analyze if it is necessary and how, if necessary, this concept will contribute to enlarge this protection of environment in a holistic approach. Regarding workers, as Mike mentions, we can say the typical remediation worker, in most circumstances, the recommendation is to be considered and managed as occupational exposed workers, applying those limits and those constraints. ICRP also recognize that in these sites, there are other type of workers that are exceptional or episodical, call for their specific skills, and for example, an electrician, a civil engineer. So these people, the working of them in relation with ionizing radiation is not part of the routine job, it is episodical. So we recommend from these people to be treated in the same line as members of the public. But recognize that depending on the situation and applying the graded approach according to the situation, some in circumstances there will be we apply for flexibility to apply specific requirements for radiation protection, and this would be adapted to the circumstances and in relation with the level of exposure. Something very important is that the management framework for all the workers had to be taken into account the all hazards approach with the balance of tools for vaccine protection, and to give them all the information on all the tools that are necessary for protection. And just to bear in mind that you can have also people that are working in workplaces in the contaminated areas, not related with the management for the protection strategy. These people are considered members of the public. What is important is that the remediation plan includes a radiation protection program to address safety and health worker protection. Important in the plan, identification of exposure scenarios, taking into account the remedial action, also of the waste management or waste disposal if necessary, performing the dose assessment, identifying which are the personal protective equipment, the information and training. Sometimes, in some cases, depending of the site, specialized training may be needed for other hazards also, and the integration of the radiological protection with procedures that are in place for controlling other hazards. So we can say that radiological protection requirements should be graded according to the risk and included in an all-occupational hazard approach. From selecting the remedial actions, just briefly, bear in mind the objective is an overall balance of the risks and benefits for the protection of people and the environment in current situation and in the future. And it is important we mention a term that is sustainable remediation, that it is the recommendation to perform a sustainable remediation. That means actions that reflect an understanding of the overall impact of the remediation activities and the assessment of safety and environmental benefits and impacts, and also what are the social and economic benefits and the drawbacks in the short term and the long term. And this is also definition from the EIA and also from AIA that share this concept of sustainable remediation. In the technique selection, it's important to take into account the reference level, but also the national policies, the availability of proven technologies, the technical capacity, the stakeholders' view, if you have the resources, the soil types, one growth locations, all the characteristics of the environment, the effects that this technique could cause to the environment, local culture and traditions, waste management, which is the time frame from the technique, the land use. So you have to take into account all these factors. We can say in general, the remediation techniques may apply at removing the source or reducing the concentration of the radionuclides, disrupting or modifying the exposure pathway, or reducing radionuclide viability. We have to take into account and analyze very carefully if restrictive management options are included in the analysis, because they may impact on the quality of life of the people and maybe have some consequence on the local economy. So it's important to take into account this sustainable address also from the economic part of the use of the land if some restrictive management options are addressed. And also, as Mike mentions, some self-help protective actions also could be identified with the people and authorities to improve the situation, such for example as local monitoring. The management of residues and waste is a very important factor in the remediation process. As you know, remediation can generate very different type of material. You can see there, I'm not going to detail. So the waste management has to be considered along all the protection analysis and remediation actions, taking into account the national policy and the legal framework for protection and for the management of waste. Obviously, the selection of the reference level may be strongly influenced by what amount of waste generated would be during the remediation. And of course, if it is possible, should be used those strategies that minimize the generation of waste, taking into account in that countries that there is no disposal route available. But we also try to remember that management waste, although it is very important to minimize, the overall objective is to optimize radiation protection as a whole, not only taking into account the waste. That is the message. The second slide from residues and waste is we recognize that it is important to bear in mind that not all the residual material would be cataloged as a radioactive waste, that these residual materials are designated as radioactive waste when they cannot be recycled, reused, or cleared for further control. And we mention also something we consider important, a recommendation to take into account to apply sustainability, sustainable approach for the management of residues and waste, trying, when it is possible, to implement reuse, recovery, and recycling in other useful products, trying to move from a linear to circular economy. This, for example, is practical to treat norm residues, for example, so to add some value and to try to minimize waste. Also, some waste can be treated as industrial or hazardous waste and not as a radioactive waste. This is important. And if you have radioactive waste, you have to follow the policy strategies and legal national framework. Something important, and I remember this was a comment from the European Commission, to emphasize that if wasted are transferred to other areas, are taken out from the site and transferred to other areas, then it is needed to establish a dialogue with the stakeholders of this area. It has to be included as part of consultation, because now you have the situation with other stakeholders. Then the fourth stage is the implementation of the remediation action plan. So once you have the remediation plan with all these factors carefully described and approved, it is important to begin the implementation. The activities should be done according to this plan and working procedures. We have talked about the waste management that has to be in agreement with the national policy. Also, in the implementation, it's important the monitoring at source, the environmental and remediation of workers. So you have to implement these monitoring programs to ensure the compliance with the objectives. Very important to also, in these monitoring programs, involve the relevant stakeholders. And of course, if something appears that is unexpected, something that is a deviation for what is planned, corrective action should be applied, and also has to be a contingency plan from some contingency that could appear during this implementation. If remediation cannot be implemented as planned, so the remediation plan should be reviewed and updated, including the objectives of protection, because some objectives could appear. Finally, we arrive at the last post-remediation management. After completion of the remediation strategy, it's important to perform monitoring, first to confirm that remediation has been successful. And we emphasize that they recommend that the monitoring is not only should be performed for sites where this define an institutional control as needed, but also from those sites that could be restricted liberated without restrictions. The monitoring programs, all the monitoring programs, not only in this stage, should be recorded, maintained, documented, and made available. It's important to have traceability of the data. And of course, stakeholders should be fully involved about this monitoring, these results, if remediation has been successful or not, because maybe further actions could be justified. For example, if the remediation was less effective than planned, or for example, in the long time appear some new technologies, and you can consider, okay, well, we can even improve the situation, but this has to be justified, and again, the process of consultation again. And it's important to have a long-term monitoring program it's important from the next generations they have a understanding of what has been done and what implies this practical process that has been done. And we recommend to have some procedures to assure that the site is not forgotten, even if the institutional control is ended. Finally, you will find in the draft this figure that try to summarize what I try to explain very quickly. You have the 5 steps, how the justification and optimization is related with the different steps, and some more important information that are more linked with each step. And you can see something important is that the stakeholders' involvement is fully and linked with all the process and with all the steps. So with that, I'm just finishing. I will try to stop share. Okay. And for me, it's a pleasure to introduce next speaker is my colleague Steve Long. That just a few words. He's assistant director for health physics measurements in the Australian Radiation Protection and Nuclear Safety Agency. And he began his career in Arpansa, taking measurements to assure the remediation works in Maralinga. And he has been measuring radioactivity at Maralinga from the past 27 years. So it will be very interesting that they can share with us all the experience of how remediation was taken in the site. So thank you very much. And Steve, you have the floor.
Thank you. So I'll just go through the case study for the Maralinga Rehabilitation Project. And I titled this stakeholder-driven remediation because the stakeholders' involvement throughout this process really did make significant differences to how this remediation process occurred. The British government detonated 12 nuclear weapons on Australian territory in the 1950s, beginning in 1952 with the proof of concept detonation in the Montebello Islands, northwest of Australia. They then detonated 2 actual deliverable weapons at Emu Field in 1953, went back to the Montebello Islands in 1956 to test another 2 weapons, which were about development of new fuels for megaton weapons. And after that, the permanent nuclear test site at Maralinga was opened. In 1956, they detonated 4 weapons in Operation Buffalo, and in 1957, another 3 weapons in Operation Antler, the biggest being a 27 kiloton blast. If that was all the British had done at Australia, this would be a fairly short talk because a nuclear weapon detonation, while it does produce fission and neutron activation products, most of those are carried into the upper atmosphere and deposited on a global scale. There is some local deposition of those fission and neutron activation products, but those activation products and fission products are mostly short-lived. And you can see on the figure on the right shows the dose rates at the ground zeros of some of those detonation sites. And now at all the sites in Australia, the dose rate is below 1 microsievert per hour. So of no real concern. And that's why throughout the rest of this talk, I won't be talking much about the Montebello Islands and Emu because radioactive decay and their remoteness meant that no remediation was required at those sites. The real contamination occurred at Maralinga due to the so-called minor trials, which are large-scale scientific and engineering experiments to develop and improve the engineering of the weapons. These were conducted between 1955 and 1963. There was some experiments on weapon initiators, the tamper compression, and most importantly in terms of the contamination on the site was the Vixen trials, Vixen A and Vixen B, which were safety trials about how safe it was to store and transport the nuclear weapons once you had those in your armory. All these trials involved radioactive material and chemical explosives. So they're all effectively radiation dispersion devices. The toxic materials they used in the site are shown here. And you can see significantly that at Cooley, they exploded nearly 8 tons of uranium. And more concerning was that during the Vixen trials, they exploded nearly 24 kilograms of plutonium on site there. And I should note, in terms of the whole hazard, there's also a significant amount of beryllium dispersed in those explosions as well. Beryllium is a chemical toxin. The uranium used was natural and depleted uranium. We've found no evidence of enriched uranium being used on the site. And the other thing is, throughout these trials, the plutonium used was simply that chemically separated from the fuels generated in a nuclear reactor. There was no isotopic separation at all. So the plutonium used, fortunately for us, contained quite a lot of plutonium-241, and that decays to americium-241 with a half-life of 14 years, which 30 years later allowed us to really look at where the plutonium was by looking at the gamma radiation signal from americium-241, because that was always associated with the plutonium. That'll come into effect later in the talk. Just to give you an idea of the extent of the contamination on the site, this is a map of the site on the left, with all those minor trial sites indicated in red, and you can see by the scale that some of those are separated by more than 10 kilometres, so the site's quite large. And to give you an idea of the investment Britain made in the nuclear test site, the top photograph shows the airstrip at Maralinga, and during the 1970s and 1980s, that was a secondary landing site for the US space shuttle program, because at that stage it was the longest airstrip in the Southern Hemisphere, and I think still might be. The bottom photograph shows the village at Maralinga in its heyday. This village was constructed to house 750 people, but to be able to accommodate up to 1,600 in peak times operation. And it truly was a village with a swimming pool, a cinema, some stores to buy goods, a church, a post office, etc. So truly a village. Just to give you a brief background, which will highlight some of the aspects of the technical group's publication. In the 1950s, Britain was looking to its Commonwealth partners for assistance in developing its weapon program, having been kicked out of the US program at the end of the Second World War. In 1956, they signed a memorandum of arrangements with Australia to enable a permanent test site at Maralinga to be established. However, in 1958, there was the moratorium on nuclear testing as public concern grew about global fallout. And also in that year, Britain was allowed back into the US program. In 1963, the Partial Nuclear Test Ban Treaty came into effect, so that the British decided they no longer needed Maralinga as a test ground. They couldn't perform above ground tests, and below ground tests they could participate in with the US program. So they cleaned up the site in the next 4 years and relinquished it to Australia in 1967, issuing a report on the residual contamination in 1968. In 1971, the Australian Defence Force decided they didn't need the site either. And the assessments of the sites at that stage all relied on the Pearce report, the British report on the contamination on the site. Nobody actually went to the site in the subsequent years to actually take some measurements of their own, unfortunately. In 1983, the Australian government decided to return the land to its traditional owners. And prior to that, the Health Minister in 1984, just a few weeks before that was due to occur, decided to send some experts from PANZA, then called ARL, to actually go have a look on the ground, just to make sure there was no risk to the Commonwealth in handing back the land. And within 2 days, there was a very serious phone call to the Minister to say, don't hand back the land. We've found very serious plutonium contamination, which was not expected. that prompted the Australian government to review how forthright the British had been in telling the Australian government what had happened to the site and what was left there. That led to a Royal Commission, which was a government investigation with the rights to subpoena witnesses and documents. That ended recommending, one of its many recommendations was the site needed to be rehabilitated, and that the government, in response to that, then formed the Radiological Consultative Group to handle stakeholder engagement and the Technical Assessment Group to determine options for remediating their site and the costings for those options. The Technical Assessment Group then undertook 4 years of characterising the site and determining various methods to reduce the contamination on site, and made some recommendations to the government. The Australian government then pursued the British government for contribution to the remediation of the site. And in 1993, the UK agreed to contribute £20 million to the rehabilitation, which is about 45 million Australian dollars. The government then formed the Maralinga Rehabilitation Technical Advisory Committee to determine the actual process that they were going to implement for remediation of the site. That remediation occurred between 1995 and 2000, and after some legal to and froing on residual liability, the site was handed back to the traditional owners in 2009. As from the end of the rehabilitation project to the present and ongoing, the site is now managed by the Maralinga Land and Environment Management Plan. The Maralinga Consultative Group was a very important aspect of that. It was in existence right from the late 80s through to 2009, when it was replaced effectively by another group, another consultative group ongoing. And it consisted of representatives from the Australian government, the British government, the South Australian government, the West Australian government, and most importantly, the representatives of the traditional owners, the Maralinga Jarrattja. And they sat at the table with equal standing to any of the government representatives. And it, as I said, was formed to facilitate stakeholder engagement and to develop what the remediation strategy should be, what the reference level should be, and the extent of the remediation. Importantly, the involvement of the Maralinga Jarrattja enabled really good access to lifestyle studies to inform the modelling of the exposure scenarios, and also importantly, understand the expectations of the Maralinga Jarrattja for the remediated site. What did they want out of it? What was going to be the end state that suited them? The Technical Assessment Group comprised 5 expert scientists, 2 Australians, 2 British and 1 American, and they then sought the expertise that it was in Australia and worldwide to help us characterise the site and determine the options for remediation. So determining the nature of the hazard, external dose, internal dose, and particles, characterise the contamination through field and laboratory studies, and looking at how that contamination travelled through the environment in terms of uptake by plants and animals, and determine the spatial extent of the contamination by aerial and ground surveys. So it's, as I said, its task was to understand the issues of proposed cleanup options using the usual, what we consider nowadays standard practice of define the source term, determine bioavailability, determine the exposure pathways, model some dose assessment, and evaluate your uncertainties. And the biggest issue they had was the sheer extent of the contamination on site. On the right, you can see a diagram of the plutonium plumes from the Vixen B trials. Each of those plumes is more than 20 kilometres long. So the contamination was really extensive. So the consideration for the Maralinga Consultative Group was, firstly, that there were some areas within the Maralinga range that were just not acceptable. The contamination levels were just too high. But the main objective for the remediation should be to enable traditional owners to access the land with minimal restrictions. The most significant hazard on the site was the plutonium contamination, which was primarily an inhalation hazard. And the critical group is infants living a semi-traditional lifestyle on their land. The traditional owners have a very significant cultural relationship with the land, which is not compatible with large-scale land clearing. So the traditional owners wanted to minimise the removal of vegetation and soil to prevent extensive environmental damage. So they insisted that only the highest level of contamination be treated by soil removal, and for that they were willing to accept that some areas may not be suitable for permanent occupation. So the criteria they ended up coming up with was the risk of fatal cancer following uptake and contamination of plutonium should not exceed 1 in 10,000 by the 50th year for someone living on site. So that is, the reference level is 5 millisieverts per year. The Technical Maryland Rehabilitation Technical Advisory Committee then used that reference level to determine actionable reference levels for the remediation. That meant that soil was removed if the americium activity exceeded 40 kilobecquerels per square metre, or it contained contaminated particles exceeding 100 kilobecquerels americium, or the density of particles exceeding 20 kilobecquerels americium was more than 10 per square metre. So the soil moved in those areas. And the use of land, primarily a prohibition on long-term occupation, would occur if the americium activity exceeded 3 kilobecquerels per square metre. If the americium activity concentration was less than 3 kilobecquerels per square metre, there will be no restriction on the land. And I highly recommend the publicly available report from the Technical Advisory Committee on the rehabilitation program for further information. The planning for the remediation program began in late 1994, and the program finished in 2000. It cost 104 million Australian dollars. It involved industrial scale land clearing of contaminated soil in a total area of 2.5 square kilometres. It involved in situ vitrification of historic disposal pits. That's where the British had buried in shallow pits highly contaminated objects. It required the burial of contaminated material on site in 5 constructed trenches with a total volume of 400,000 cubic metres. And the signposting, which you can see the sign on the right-hand side of the restricted land use area, which had a total area of 400 square kilometres. The sign is in traditional Radiological language, and the pictograms mean there's radiation, it's okay to hunt, don't camp there. Throughout the project, all workers were treated as occupationally exposed. So they operated in sealed vehicles with the positive pressure cabins and HEPA filter filtration. They were required to change clothes and shower after leaving contaminated areas, and the clothing was laundered on site. There was air particulate monitoring throughout the remediation program, and all the workers received monthly lung monitoring assays to ensure that they had no uptake of contaminated material. Ongoing management of the land is via the Maryland handback deed in 2009. That provides the land is managed by traditional owners, the Maryland Jarrattja, and they provide an on-site caretaker for that. The Maryland Land Environment Management Committee was formed in 2009 and took over from the Maryland Consultative Group. Its membership comprises the Commonwealth Government representatives, South Australian Government representatives, and representatives of the Maryland Jarrattja. Again, the traditional owners are equal standing at the table in that management committee. And it's there to oversee the Land Environment Management Plan and primarily the maintenance of the hazard reduction measures implemented during the remediation program. The site is licensed as a radiation facility by South Australian Government, and since 2015 has been operating a commercial tourism business managed by the Maryland Jarrattja. although site access is still limited, as with most First Nations land in Australia, you require a permit to enter that land, and the Maryland Gujaratja restrict the entry to the number of tourists they can comfortably accommodate throughout a year, which at the moment is about 1,200 tourists a year. The Maryland Land Environment Management Plan, which is the plan for ongoing management of the site, provides for institutional management, records management, maintenance of the hazard reduction measures implemented during the remediation program, periodic radiological safety assessment to ensure that the dose criteria is not exceeded if new information comes to light or uses of the land change from that assumed during the MARTAC period, conservation management, auditing to ensure compliance with the land, and contingency planning to monitor and manage unanticipated events. And that plan is reviewed every 5 years by the committee. And that's it from me. So I'll hand back to Mike to start taking questions.
Great. Thank you, Steve. Excellent presentation. I realized when Analia gave you a nice introduction that I had just jumped right into her talk. So I wanted to thank her in particular for being the co-chair of the task group, and to note that she is both with the Argentina's Nuclear Regulatory Authority and a member of Committee 4, and serves on several task groups. So thank you, Analia, for your excellent presentation as well. I think Kelsey pointed out that we're taking questions through the Q&A tab at the bottom. I think it's at the bottom of your screen. It is mine. Should just be over beside the chat. There's a function in there where participants can sort of vote up. If you hit thumbs up, it means that you also think that question is important and that we should answer it. I'm going to try to moderate, and I'm going to open the Q&A now and see what we've got. So the first question I'm seeing in terms of up votes is from Augustin Johnson, who I've known for many years, and he says, of course, the long-term objective should be to attain exposures below 1 millisievert per year, but there are situations with local impact, no widespread contamination, such as the Swiss watch industry. In such cases, it may be justified to pursue right away a low dose so that people can preserve peace of mind, ignore the situation, and so immediate decontamination or confinement of the site may be the right option. I think this is more of a comment, and I would ask any of my fellow presenters if they also agree. I think, yeah.
I agree with you, Mike.
I'm sorry, Ludovic. Yeah, and Ludovic Vaillant is the secretary of the Task Group 98. So thank you. What were you saying?
No, I was just saying that I agree with you. It's more a comment, I think, from Augustin. Anyway, this case study was addressed within the report, and a reference level of 1 millisievert per year was picked up by the Swiss authority, and it's a very good example, and I invite you to read carefully this case study.
Great, thank you. So moving on, the order that I'm getting, let's see, I'm having a little trouble managing the questions here. Since we just discussed Augustin, I'll go back in just a minute. Kim Baines says, are conceptual site models discussed? A conceptual site model is the foundation of the remediation process at every stage: site characterization, risk, safety assessment, planning, and post-remediation when required. And Leah, I think we do discuss conceptual site models.
Yes, we mentioned in the draft conceptual site models as an important fact from the detailed characterization that is needed. I'm trying to emphasize that to take the reasonable actions of justification or optimization, we need to know the site that may be defined by different models. We need to define a conceptual site model of the site, but which is important to understand all the risks that are involved: hazards, radiological hazards, non-radiological to the workers, public and environment. I think this is the recommendation.
Thank you. Here's a question for you, Steve. David Bremner asked, were vehicles and equipment used at Maralinga contaminated after use, and did they have to be consigned as radioactive waste?
So certainly there were a lot of vehicles used. As I said, it was industrial scale land clearing. You saw on one of my pictures a really large earth-moving piece of equipment. So they certainly were used. Where possible, they were decontaminated. So there was a facility on site where they could be high pressure washed and decontaminated there, which they also need to be for maintenance of the vehicles as well. There were a few vehicles, not the whole vehicles, but some parts of vehicles disposed on site. But generally, the vehicles were able to be decontaminated.
Great, thank you. Back to Augustine, the question about, or noting that in figure 1, he likes the figure, but said that he's interested in our exposures not certain to occur category, and wonders if it would be useful to give more guidance on how to manage probabilistic aspects of the exposure situation. Kelsey, it looks like you want to answer this. Or maybe I'm misreading that.
No, sorry. Yeah, I'm just recognizing that it's being answered live, and then once it's done, I remove it from the.
Oh, okay. It's a it's an artifact of the Q&A system here. So, Analia, do you have a view on?
I understand the question that maybe is important to give some recommendations or more advice how to select a risk criteria or how to address this how to select the criteria to address this potential of exposure not certain to occur in existing exposure situations. It's true that we are just suggesting an example of diversity by an example of how this risk criteria has been selected. Maybe we can be a little more deep to give and try to give some more recommendations. This is what my understanding from the comment. Thank you.
Thank you. And there's a similar comment here from Wayne Otway, who says the report does not give a numerical value for risk constraint, only hinting that one could be used. However, in Dalgety Bay, the overall risk to health assumes a 1×10⁻⁶ probability of 1 millisievert dose. He said, which is about 1×10⁻⁹. That is very low compared to the risk constraint recommended for planned exposures, which is 1×10⁻⁵. Is this level of risk being recommended, or should an alternative value be highlighted in the report? I open this to all of you, but I would say that this was a decision, I think, between the stakeholders and the regulators in Scotland, and so that it may be that that was a site-specific and case-specific determination. But do others have a view?
I think Maralinga gives the contrary view, where the stakeholder engagement said, let's stick with 5 millisieverts a year. So even though it's not the probabilistic, we've got in our examples that really large range of reference levels of very low to reasonably high, but not so high as to be outside that range of recommendations.
Yes, maybe I can add that what we try to recommend is that you cannot specify a value, a generic value, because each situation is unique and depends of the stakeholders, depends of the values, depends of all the factors that were mentioned. So maybe from one country, which seems a very high reference level, for others, so this has to be agreed and discussed, taking into account all the factors. Also, I take the opportunity, I say very quickly that then the state is much more than was explained. Yes, I just wanted to clarify that Then the state is a criteria that is different from the reference level, and it involves other things that the reference level is. But of course, it is more explained inside the text. Thank you.
Thank you. David Bennett just added a comment that in the UK, there's a risk constraint of 1 in 100,000 and a risk guidance level of 1 in a million. So in the absence of upvotes, I'll go chronologically in terms of who asked first this today. I see a question from Kim Baines from earlier. How are existing exposure situations created without or not in line with ICRP requirements considered when they are on a regulated site where planned exposure situations exist? And I think I mentioned in my talk that we consider land on site controlled by the operator or the regulator to be out of scope for our report. Is that consistent with what others? Yeah. So I think that's that. Anonymous asks, thank you for the overview of main points. I wonder whether the introduction of the existing exposure situation can be seen as a graded approach to the RP system in itself. I'd have to think about that, but maybe. What do others think? Let's see. Terry?
Yeah, I can just briefly respond to that. Clearly, the graded approach is part of the discussion on applying the principle for existing exposure situation. And as I already mentioned at the beginning, some different reports already address that, notably for RADOM, for NORM, and we are in the process of further investigating this aspect in different task group of ICRP. So for sure, this is an issue to be further detailed, and this is a key point for existing exposure situation to better define what we mean by graded approach.
Thank you, Terry. And I think I need to refresh my upvote tally here. I see that the next one has 4 upvotes already from Wayne Oatway. Would contamination discovered during a planned activity, for example, discovery of previously unknown contamination during redevelopment of land, fall outside the scope of this report as it is a planned exposure rather than an existing exposure situation? Who would like to take that?
So planned exposure situations are where you're already dealing with radioactivity. So the question isn't quite right. If you're redeveloping land, you're assuming there's no radioactivity there. So it's not a planned activity. It'll still be an existing exposure situation if radioactivity existed there, because you weren't expecting the radiation. Just because an activity is planned doesn't mean it's a planned activity in terms of radiation protection.
Right, okay. Got that, everyone? Thank you, Steve. Paul Sharp is next with one potential problem with setting a reference level above background is in the determination of background. In many cases, especially in formerly utilized sites, areas, there may be insufficient data available to determine local background levels that existed before the site was used. Variations in geology, soil types, and atmospheric fallout need to be considered as well. And I think we say pretty much the same thing in our report, if I recall correctly. It's important to find sort of a surrogate site that has all of the the similar geology, but has not been contaminated from the source under concern. Do we agree with that? That we have acknowledged that in our report. Okay. Scott Muhlman says, thanks, Steve. You mentioned no camping in Maralinga. Is there an anticipated date where those restrictions are likely to be lifted?
I think as the traditional owners really do take more responsibility for the site over time, and that's what's happening now, those restrictions can probably be lifted because they'll know to manage, and it's not, and by camping I mean it's long-term camping, not camping overnight, but camping for several months. So I think that's one of the issues that we're starting to discuss now is do those signs need to be maintained, or will just the sheer management of the site by the traditional owners be sufficient to impose that restriction?
Great. There's a question, Nair Irfanian Subakhtani. I'm sorry if I don't get your name right. Thanks for all the presentations. Are there acceptable limits of radiation for post-monitoring after remediation of sites, or explained in the publication? Analia, you're answering. And there's a similar question. I'm going to see if I can find it while you're answering that.
No, I was answering that post remediation or post monitoring is to verify and to comply with the objectives that you have achieved. There is not that appears new reference levels or new objectives. Maybe I don't understand very well the question, but I thought that if it is decided that you need to perform a new remediation because it was not successful or because you have other technologies, then again, you have to redefine a plan, define first if it is justified, and then to optimize and begin the process again. But if it is a monitoring for the final stage, it's just to verify the objective that you have set at the beginning. This is my answer. I was just trying to write.
Thank you. I'm trying to find, though I noticed earlier that someone said, if, and I'm just paraphrasing because I can't find the actual comment, but someone else had said that if you achieve your remediation goal, why do you need ongoing monitoring, something like that? So I think I'll try to find, as we scroll through, maybe I'll find the actual comment, but I think the answer to that might be that it's it's a decision for national regulators and in consultation with stakeholders how much additional monitoring is needed. And I think from the Maralinga case study, there's a good example of when there may be reasons to do continual monitoring because there may be things there that have as yet gone undiscovered, and particularly for the older sites that were remediated before modern, modern recommendations. And the next question, Abdel Wahad says, can we have an idea about doses received by workers? And I'm not sure if I guess maybe this is in relation to Maralinga, Steve.
Oh, I know. There was the doses due to the rehabilitation by workers was zero in all cases. Nobody, or less than measurable. Let's put it that way. The low monitoring didn't show anybody with any plutonium in their lungs.
Right. And the next question for you as well, could you please explain how the reference level of 5 millisieverts was decided? Was the 5.5% perceiver taken into account for a population of 10,000, or was it decided based on a different approach?
So the 5 millisieverts per year is for a reference person, and that reference person was a toddler living a semi-traditional lifestyle on site. And it was a balance between the amount of environmental damage you would have to do to get a level lower than that, and the risk to the population or the potential population. So it was a balance of those two factors. And really it also took into account the lifestyle of the traditional owners as well. At that stage in the 80s and 90s, the average life expectancy of a traditional owner living the semi-traditional lifestyle was about 55 years old. So, it's a balance of all those things that had to be taken into account.
And the next two questions are also regarding Maralinga. You were very popular this morning, today, Steve, sorry. And they relate to stakeholder engagement. At Maralinga, is oral communication of land use restrictions important for the Charucha people? And if yes, is it continuing to be effective? And how is that being measured?
So the short answer is over the last few years, we've discovered just how important the oral tradition is with traditional landowners. And we're about to begin, literally in 2 weeks' time, a program of annual radiation risk workshops for traditional owners held on site out there. So literally in 2 weeks' time, a couple of my colleagues are going out to speak to the Radiological Rangers, who are now working on site in terms of environmental protection of the area, to work with them on their understanding of the radiation risks associated with the site and the history of the site.
Right. And Martin Tondel asked a similar question about asking about insights into how the dialogue with the traditional owners went, noting they were never consulted before the test started, so no surprise if they reacted negatively when their land was contaminated. How was frustration and compensation handled?
So the land was taken off the traditional owners without consultation, because at that stage, much to Australia's shame, they weren't even considered Australian citizens at the time. So they were, when the land was going to be handed back to them, they were very happy about that, but concerned about the contamination of the land, which they knew about from other parts of the history. So they were aware the land was contaminated, but they were very, very keen to take ownership back of their land. So as I said, they've got a very strong cultural relationship with the land,
Right.
And they wanted to take ownership back regardless. They were compensated for the fact that we couldn't hand it back in a pristine state. We couldn't remediate back to a pristine state, so they did. There was some compensation for that. But the big gain to them was they got their country back.
Right. I think, Analia, the next two might be for you. Hassan Almasi says, with respect, is simulation commonly used to investigate the environment?
Yes, of course. You can use models to apply for investigating which is the doses involved and what can happen in the future also, because of the dispersion of the material. And yes, of course.
And Kembain says, site end state means much more than what has been explained. Hopefully the publication explains this. And I think this comment was made while you were giving your presentation, and you were saying that the site end state was related to I think that was when you were saying it was related to the residual dose, and I think that was the commenter's point.
Yes.
Yeah. Anything more you want to say about that, or? I think we acknowledge that there's more than just residual dose involved in defining an end state. Yeah.
Yes.
Because also then the state is related with the benefit of the use. There you in the selecting of then the state, it is also the sustainability that you have to take into account, the economic, the social, the environment. And I also see very quickly a question about if a site, this is my understanding, if a site like it was remediated, could be converted in like some industrial or something again. And of course, it depends. It can be from recreation, it can be a park, it can be an industry. That this depends of the future land use. That is very important, and will be to follow all the end use and the criteria. But yes, anything could happen with this site that is remediated. It will depend of which is possible and what is the need of stakeholders. For example, if they need another industry. Well, okay, yeah. but with safety.
Yeah. Martin Tondel is asking, should the reference level be applied on all persons, or is it an average exposure in the population? And I think from my experience in the United States, we use terms like average member of the critical group or reasonably maximally exposed individual. I suspect many national authorities have similar designations, but with the ICRP, I
It's
think
the
for the ICRP.
concept of I think it's the content of the representative person.
Yes, yes.
That is an average. It is not the most exposed individual, but it's an average individual of the most exposed population.
Yes, yes, very similar to
yes.
So I think I'll just go down the list here. Karul Anwar bin Abdullah says, what is the lab investigation that can be considered for medical surveillance of the worker during immediate exposure and long-term follow-up? That's really a little bit outside the scope of the Contaminated Sites report. I think medical surveillance for radiation workers is commonly applied in, just routine medical surveillance, but others have a view on that?
No.
Okay.
At Maralinga, when they were remediating the site that was contaminated with uranium, there was medical surveillance of urine analysis for uranium was the way to estimate their intake of uranium during that for those workers. So,
and Tawfiq Ahmed from India says, what are the challenges associated with the long-term management of radiologically contaminated sites, and how can sustainable practices be integrated into long-term management of these areas? And I think that question is, I don't want to be too curt, but I think the answer would be read the report, because I think that's really the substance of the report is how we're hoping to answer those questions in the full body of the report. I don't think it's a simple answer.
They're not simple.
Yeah, but thank you for the question, and I encourage you to read the report and give us your thoughts on whether we missed anything there. Shannon Thompson says, how much of the Maralinga site cost went to ISV of pits? Forgive me, I forget what ISV is.
in situ vitrification.
Oh, right, yeah.
So from memory, I think the budget for ISV was $30-something million. But ISV was abandoned halfway through because of an industrial accident associated with the process. So not all that money was spent on ISV in the end. And the pits ended up being simply excavated and reburied, the material reburied at a more substantial depth.
And I just refreshed our upvotes, and the leader right now is Olga Gehrman. Hi, Olga. Remediation does not mean that all radioactivity is completely removed. Also, in situ disposal of radioactive material can be used in some cases. These and all other reasons might require long-term monitoring and maintenance of sites. Thank you. That's a nice addition to the comment we were making earlier about the need for long-term monitoring. Thank you. We have one now, Yasser Alberto Mena de Valverde. I hope I'm getting your names even approximately right. Are environmental factors, heavy rains, earthquakes, etc., taken into account in terms of monitoring after remediation? I don't know. That's a good question. Certainly, I think long-term assessments often do consider weathering and erosion, but episodic events like that, I'm not sure that we specifically mentioned it in our report. But to others,
yeah, I think a lot of those factors will be taken more into account in terms of characterising the site in the first place and determining your remediation program. If it was an earthquake-prone site or whatever, you might not want to dispose of radioactive material on site, for example, or that might change how you dispose of material. And if you get monsoonal rains, that might also change. You factor into how you think about remediating the site.
Right. Shannon Thompson asked, does ICRP compile a site remedial database of risks versus cleanup costs? This would not be an efficiency metric, rather could be used to show estimated or projected cost with local factors, remoteness, land values, stakeholder inputs. It could be interesting and valuable. Yeah, I agree. It could be. I don't know that we have such a database. I think maybe, again, in specific countries, national authorities or regulators might have assembled something for their own country or region. I'm not sure about that. I know in the U.S. when I was at the Environmental Protection Agency, we did some database for site cleanup decisions and costs, but I'm not sure.
I have heard, for example, that there is a network that is Environet from the agency, that they are trying to prepare a database to share with the different countries, so as examples of also of experiences, to share experiences of the different factors affecting the remediation that have been performed, and that would help as a lesson learned also.
Right.
It would be interesting.
Anonymous says, from your case studies involving impacts on indigenous persons, has traditional knowledge been utilized for remediation and evaluation? And I know in the report we mentioned several times the value of traditional knowledge, but Steve?
Certainly at Maralinga it was invaluable.
Yeah.
As I said, without the traditional owners being involved, I don't know whether the studies on their lifestyle would have been as comprehensive in terms of input to the dose assessments. And certainly, as I said on several occasions, their view of their cultural association with the land and their view on minimizing environmental destruction of the land was a real key in driving the end state for the remediation at Maralinga.
Right. Augustine again says, thank you for the nice presentations that address the principle of justification very well, but why does the term not appear explicitly in the overall conclusions? Augustine, the last thing we write when we write a report are the conclusions, and I think that's just oversight. So thank you for the comment, and that's really why we're the kind of input we're hoping from the public consultation, and I will make sure that we do address or mention it in the conclusions. Thank you. Let's see. Things keep shifting on me, Kelsey. I have to scroll up and see where we are. Oh, Daniele Jeffrida. Hi, Daniele. Thank you, Mike, Annalisa, Steve, Ludovic, and other task group members. Interesting work, presentations, and discussions. Well, you're welcome. We've enjoyed giving this presentation. And I'm seeing some still here that haven't been cleared, but we've answered. Zulfikar Ali says, right, Olga, but is it more efficient to find ways to send this long-term waste far away from human societies into deep space or many permanent deep geologic repositories? I don't think we're prepared to make that determination today. But that's interesting. Thank you. I just going to take the ones I'm looking at now. David Schaefer says, well, no. Let me see if it disappeared on me. Sorry.
I think, Mike, there is an interesting question by David Bennett.
Okay. And then we'll go back to David Schaefer. Yeah.
It is moving, so it's difficult.
Yeah.
It would be really helpful to have a clear delineation between planned exposure situations and existing exposure situations. Do you think this is possible? What about the planned disposal facility in a contaminated area? Well, I think this is very interesting. I think that at first stage, it's important to clarify what is planned and what is existing. And in this sense, there is a task group on ICRP, it is task group 127, to first understand that concept, because we find in the discussion that it's not easy. Sometimes it is some mixing ideas. So to clarify that, and then I think maybe we can clarify a little more for that complex side that you have, because I see some questions about that you have a planned exposure situation, but you can have inside like an existing exposure situation. As Mike mentioned, we are clear that if you have a site under a framework of planned exposure situation, if it goes under the commissioning, it's not existing, it is the commission, it is a planned exposure situation. And also if you have some localized contamination or some maybe expected deviation, that is also treated in the context of planned exposure. But my understanding is that we are talking about some special sites, long sites that may be very huge, and that you can have some situation that are more related with the characteristic of existing exposure situations. So maybe we can treat a little more if we have some recommendation to give to that specific sites. It is my understanding from 3 or 4 questions, I think I saw in the same line.
Yeah. If my tally is correct, I think we're going to get through our questions here because we have about 10 minutes left in the time. There's a comment from David Schaefer to Steve. Thanks for the information on plans to continue education training for traditional landowners at Maralinga. I had heard concerns that site knowledge was being lost, and the U.S. Department of Energy has started similar efforts for some large tribal nations. And that's just a comment. And thank you, David, for that. Will Monroe says Dalgety Bay involved erosion, which exposed the particles initially, and then remediation following the discovery of the particles. But climate change surely needs to be considered. And I think the task group member who prepared the case study, Dr. Corinne McGuire, has indicated, I think, that certainly erosion and I don't know if it's explicitly called out as climate change, but that's really the source of the release of these discrete particles into the environment. So I think that's certainly being considered. Things are bouncing around. I don't know if we have any new. Let's see. The first 2 we've already answered under. Bijan Samimi says, "Oh, thanks for your presentation." Thank you for joining us today. Oh, and now we're just getting some nice thank yous from various participants. I don't see any more questions that we haven't answered. Kelsey, you can let me know if I'm missing anything, but oh, here's one. Anonymous says, if you plan an activity or facility, it cannot be existing exposure situation because you can plan to apply all relevant RP and safety requirements before the facility and activity starts. And I think, yeah, we acknowledge that as well in the report. Thank you. And now just a bunch of thank yous. I really, well, I'll stop the Q&A here because I think we've covered all of the pressing issues that you've raised. If I could just invite you, if you haven't yet, to download our report. The public consultation period runs through September 20th, and our task group will then eagerly review all of your comments and hopefully use them to improve the report before publication. And I would thank all of my fellow participants and ask them individually if they have any comments they'd like to make before we sign off. No? I see a lot of heads shaking no. Okay. Well, then I think Kelsey, I guess it's okay to end 7 minutes early. Nobody's going to complain about that.
I don't think so. Yeah.
Okay, great. Thank you all for joining us. This has really been a very helpful session for us, and look forward to getting your comments through the public consultation. Good.
Yes.
Bye.
Thank you.
Thank you very much.
Bye-bye. Yeah.